This is an ultrasonic sensor. It uses sound waves, ultrasound, to measure distance. It emits high-frequency sound pulses, typically 40 kHz. In our case, we send sound wave and measure the duration of sound wave received on receiver unit. As we know, distance covered equals speed of sound times time taken. Speed of sound equals 343 meters per second. For ultrasonic sensor we use distance equals speed of sound times time divide by 2. Why divide by 2 is because sound have to travels from source and returns to receiver. We use SR04 sensor to measure distance and ESP32 for triggering signal, reading in pulse time and display value. This sensor support direct GPIO, one-wire, I2C and UART protocol. Here we use 2 GPIO pins for trigger and measurement, and serial communication for data display on serial monitor. At backside of sensor, there are labeled M1 and M2. By shorting these, we can either use GPIO pin or one-wire or I2C or UART protocol. Now, we need to transmit ultrasonic sound and receive it. How are we going to do that? We send high and low signal to trigger pin of sensor and we will measure duration of sound received in echo pin. Here we use ESP32 module. You can also use Arduino Nano or Uno. Here, ESP32 works on 3.3 volts and sensor works on 5 volts. Output voltage of sensor is nearly halved and feed to pin 18. Let's us define GPIO pin trig_pin 5 and echo_pin 18. Inside setup function, we initializes serial communication between the ESP32 and a computer or another device and set boot rate to 115,200. We change working mode of GPIO pins. We make pin 5, which is trig pin, as output pin. This will send trigger input of approximately 3.3 volts to ultrasonic sensor. Now we make pin 18, which is echo pin, as input pin. We will explain this shortly. Now define get distance function. First we will send low signal to trigger pin of sensor, which, follow by high and again low, and we put delays in between. There the pulse in function measures the duration in microseconds of a high or low pulse on a given pin, which in case is pin 18. In ultrasonic sensors, the echo pin goes high when the sound wave is sent and low when it returns. Now we calculate distance in centimeter. We use speed formula. Received duration is in microsecond. Here 0.0343 is factor calculated from speed formula. We divide it by 2 because we need one-way path distance. We now display distance in serial monitor. This is simple demonstration of using ultrasonic sensor for measuring distance. Call get distance function inside loop function. Now compile and upload the code. Now we increase the distance of obstacle in steps. From this technique we can measure distance, object detection and obstacle avoidance in robotics and drones. In future video, we will explore more on it. If you find this video helpful, please like and subscribe to the channel. It helps a lot.